All right, maybe we can start. Hello, everyone. I hope that you are enjoying CAIP'21. With me is Priya Donti. She's our keynote speaker for today. Priya is a PhD student in computer science and public policy in Carnegie Mellon University. She's also the co-founder and chair of Climate Change AI, an initiative to catalyze impactful work in climate change and machine learning. Her work focuses on machine learning for forecasting, optimization, and control in high renewable power grids. Specifically, her research explores methods to incorporate the physics and our constraints associated with electrical power systems into deep learning models. Priya is a recipient of the MIT Technology Review Innovators Under 35 Award, the Siebel Scholarship, the US Department of Energy Computational Science Graduate Fellowship, and Best Paper Awards at ICML, Honorable Mention, ACM Energy, Runner-Up, PESI, the Duke Energy Data Analysis Symposium, and the NeurIPS workshop on AI for social good. Today, she will be talking us about tackling climate change with machine learning. Priya, the floor is yours.
All right, thanks, Joao, for the kind introduction, and to all of the organizers for putting this event together. So can you see the slides there? Okay, great. So today I want to talk about climate change and machine learning, both ways in which AI and machine learning can be used to address climate change and broader considerations for aligning the use of AI with climate change overall. So diving in. So climate change is, one of the most pressing issues of our time, and we're already feeling many of its effects, including droughts, wildfires, storms, and flooding. This has massive implications for human health and well-being, for our food systems, for biodiversity, and in general for every part of our society. Every part of our society either, has been or will be impacted by the effects of climate change. And perhaps as put more succinctly by the UN Intergovernmental Panel on Climate Change, the IPCC, climate change will amplify existing risks and create new risks for natural and human systems. And unfortunately, these risks will be borne disproportionately by disadvantaged and minoritized populations around the world. So this is a huge equity issue as well. So in order to avoid the most severe impacts of climate change, we as a society need to act fast. So when people talk about climate action, there are often two main components to this. So the first is mitigation, which means reducing the amount of greenhouse gas emissions that we release into the atmosphere in order to curb the extent to which climate change actually occurs. According to the UN Intergovernmental Panel on Climate Change, the IPCC, we as a society will need to reach net zero greenhouse gas emissions by 2050 in order to limit global warming to 1.5 degrees Celsius. And this is sort of a number that has been agreed upon as sort of, limiting some of the worst effects of global warming. If you heard this saying, we have 10 years to act on climate change, this is actually the target it's based on. So to get to net zero emissions by 2050, we'll have to make a lot of the, decisions about societal decisions, policy decisions, infrastructural decisions by about 2030. And while this, exemplifies the need for really rapid action, it's also worth noting that climate change isn't, an on-off switch centered around some specific target. Every unit of warming that we avert is ultimately better for society. So the second component of climate action is adaptation, which means building resilience to the consequences of climate change that we're currently facing and that we'll continue to face, especially given that greenhouse gas emissions that are already in the atmosphere will continue to hang around for a very long period of time. While mitigation actions are in some sense, agnostic to location, reducing 1 ton of carbon dioxide anywhere will help the climate everywhere. The adaptation actions tend to need to happen more locally. So each individual community needs to make sure that it is, protected and shored against the specific risks that it may face. So this requires, in some sense, local actions at a global scale. And in general, in order to work on both mitigation and adaptation, we need rapid action across society, across different sectors, academia, industry, policy, civil society, everywhere. And there are lots of kinds of things that we need to do in order to make that happen. But AI and machine learning can also play a role in helping with that. So about 2 years ago, a group of us from across academia and industry wrote a paper called Tackling Climate Change with Machine Learning that tries to detail exactly, what are the ways in which AI and machine learning can help us with climate change mitigation and adaptation. The paper itself is, a short 100 pages, but I definitely encourage those of you who are interested to check it out. And there are also some summaries available online for those who want to see sort of a shorter version. In the paper, we talk about, various ways in which AI and machine learning can help mitigate emissions in sectors like electricity, buildings, transportation, agriculture, forestry, industry, and then also various ways in which AI and ML can help us adapt to a changing climate by, for example, enabling more localized climate predictions, by helping us build more resilient, ecological, infrastructural, and social systems, and by also facilitating disaster response. So while we detail, many dozens of applications in the paper itself, I'll try to give a quick overview of some key themes that emerged across these applications. So one of these involves gathering information. So there are lots of situations in which some decision maker maybe needs some information to make some decision about climate policy or some kind of action that would, service a climate change mitigation or adaptation strategy. But whereas that kind of, relevant on the ground information may not be available. So there have been a lot of applications using AI and machine learning to gather proxies for information that may not exist by analyzing large streams of data like satellite imagery or large corpora of text documents. So for example, there's an international coalition of organizations called Climate Trace that recently released a sort of global greenhouse gas emissions inventory, sort of an independent global greenhouse gas emissions inventory using sort of sensor satellite imagery and AI analysis in order to provide sort of, again, like independent, trusted, open source, third-party estimates of the emissions from around society. There are also initiatives that, try to pinpoint deforestation from satellite imagery to try to prevent deforestation, or map the locations of solar panels in order to help with energy systems planning and management, or understand crop yields for climate change adaptation purposes. So you can sort of detect the, crop cover or the amount of crops that are being produced on a specific piece of land using satellite sensor imagery, et cetera. So the image on the slide is an example of a crop mapping application. Another big theme is forecasting. So there are, lots of applications of machine learning to, for example, predict solar and wind power production in order to manage electric grids, or to forecast things like transportation demand in order to inform transportation system planning, or create localized forecasts of extreme events to enable better disaster response policies at the local level. Here, the image on this slide is it's a mapping of sort of the amount of solar power produced by different solar plants around the UK from a nonprofit called Open Climate Fix. And that nonprofit is working to sort of improve forecasts of solar and wind power in order to, again, kind of integrate renewables into electric power grids. There are also lots of applications where AI and ML can help increase the efficiency of a real world system in operation. So for example, heating and cooling systems make up more than half of the energy use associated with buildings. And there are lots of, associated applications in, optimizing heating and cooling in residential and commercial systems in order to make them more efficient. There are also applications in, optimizing freight and supply chains to reduce the emissions associated with those, and also to optimize, food purchasing systems in order to reduce food waste. Similarly to that, there are lots of inefficiencies in real-world systems, and analyzing large-scale sensor data can help us identify those inefficiencies either in real time or proactively before they become a problem. This turns up in places like detecting methane leaks in natural gas pipelines. Methane is a really potent greenhouse gas, something like 40x times more potent than carbon dioxide. And so machine learning has been used to try to detect where leaks in natural gas pipelines are occurring, either ahead of time or after the fact, so that they can be fixed very quickly. Machine learning is also used to try to make, infrastructure resilient to extreme events that might be exacerbated due to climate change. And it's also used to just try to make low carbon infrastructure more efficient. So the image on the slide here is an example from the German rail operator Deutsche Bahn, where they're using large scale sensing and AI for predictive maintenance in order to, maintain and make more efficient the rail infrastructure in order to make trains sort of more competitive against other maybe higher carbon forms of transportation. Another category of applications that is maybe less expected is the use of AI and machine learning to accelerate scientific experimentation. So there are a lot of efforts to try to create new clean technologies like next generation batteries or electrofuels. And there's a lot of experimentation that goes into that. So you want to figure out, I want to design a battery. Okay, which material should I synthesize next? I need to then actually synthesize it. I need to then test it out, which may take months and months. And then I repeat that process over and over again. And that overall design cycle can take a very long time. So AI and machine learning have been used to try to, analyze the outcomes of past experiments in order to recommend which experiments might be most fruitful to try next. And that way to ideally cut down on the total number of design cycles until you get to a successful, for example, battery design. And one last theme I'll point out is that AI and machine learning can help approximate time-intensive simulations that are used to make decisions in climate-relevant areas. So these include things like large-scale climate models that are, really time-intensive and energy-intensive to run, and they can only really be run at large spatial resolutions. So AI and machine learning have been used to approximate portions of these models and make them less expensive and less intensive to run in a way that allows them to produce, more granular insights that are potentially useful for decision making. So that's climate modeling, but this also comes up in, for example, optimizing electric power systems. Sort of the algorithms that we use to optimize power systems are really large and slow, and machine learning has been used to try to speed those up in order to allow us to manage power grids in a way that's more dynamic and well suited for the integration of renewable energy. Machine learning has also been used to speed up city planning models that try to, for example, plan cities in a more efficient manner, but are, again, very intensive to run. So that's sort of a whirlwind overview of the different themes sort of at this intersection of, of using AI and machine learning to help with climate change. But there are some considerations and caveats when thinking about how to actually do work in this space impactfully. So to give some context, of course, as I mentioned earlier, climate change is a really cross-cutting issue. We'll need to be doing many, many different things in order to address it. And not every single climate change strategy needs AI and machine learning. AI and machine learning are not silver bullets here. Where AI and machine learning are applicable, they're only one part of the strategy. So for example, if you're going to be, using AI and machine learning to optimize the heating and cooling systems in buildings in order to make those more efficient, if you don't insulate your building, if you don't do sort of the other, important things that are needed to do that, then you're leaving a lot of impact on the table. So it's really important to think about how does my use of AI and machine learning, maybe for a climate relevant strategy, fit into the broader scheme of things. It's also worth noting that, many of the impactful applications of AI to tackle climate change may not be flashy. So for example, I mentioned predictive maintenance, right? Just making sure that train systems don't break. Maybe not as flashy as nuclear fusion, but very, very important to making sure that we actually are able to switch over more readily and in larger volume to low carbon transportation systems. So in addition to this, we also want to think about considerations around deployment. So many of us who are coming from an AI and machine learning research background, right, our work focuses on methods and often developing very fancy methods. But sometimes in many of these settings, simple methods work. There are opportunities for methodological innovation, but it's worth trying the simple thing out first. It's also worth being aware of rebound effects. So rebound effects occur when a system is made more efficient, and as a result, that causes it to be used a bit more. And this can sort of partially or even fully cancel out maybe the emissions benefits of having made the system more efficient. So, for example, if you make supply chain systems more efficient, you make them cheaper to run, then companies may use them more, right? And then sort of that brings back some of the emissions that you had initially saved. So it's really important to be aware of these kinds of effects and sort of both develop your technology in a way that is aware of that, and then also, try to inform policymakers about ways in which policies can actually help avoid some of these effects. So, for example, by changing up the objective function in your algorithm, we're asking policymakers, hey, if you put a carbon price on this particular thing, then my algorithm would be optimizing for the correct thing. Another thing to think about here is equity, both in terms of, who owns the thing that you're developing and who can access it. And when I say ownership, I mean that very broadly. So for example, who was, able to help in actually scoping the particular problem that you're working on, or choosing that particular problem, who was able to, have ownership over how that actually went forward and how the development actually progressed. So it's really important to think about, especially given that, AI and machine learning techniques are often most available to those with the most power in society already. How can you think about this very proactively when developing AI and machine learning solutions in the context of climate change? And then finally, partnerships are key, sort of to both, thinking through domain relevant considerations, thinking through all the relevant pitfalls. It's really important that sort of, researchers and deployment partners, end users, policymakers collaborate together, and also other affected parties who, maybe are not along the, for example, commercialization pipeline of a particular technology. Maybe they're not the ones who will be paying for it, but people who may still be affected by it. It's really important to sort of keep all of these folks in the loop and really collaborate strongly during the process all the way through, scoping, development, deployment, and scaling. So far, I have talked about sort of one big way in which AI and climate change are related. And this is how, AI can help with various strategies in climate change mitigation and adaptation. So again, reducing the impacts of reducing the extent to which climate change occurs, and reducing the impacts that we actually face. That said, AI, like many other tools from science and engineering, is just a tool. And like all of these other tools, it can have varied impacts on society depending on how exactly it's used. So I actually want to go through some of those impacts and sort of spell those out in detail. So one of them is that AI can be used for applications that directly increase emissions. So I've talked about, again, places where AI can be helpful in climate action, but AI can also be used in ways that are actively counterproductive to climate action. There are also some AI applications that maybe don't feel like they directly impact climate change, but maybe they actually have, uncertain or systemic impacts that could or could not affect climate change in a particular way. And then lastly, AI algorithms, they run on computational infrastructure. This infrastructure uses energy, and it also uses hardware. So, what is the sort of energy use and sort of emissions impact of AI itself as it actually runs? So I want to dive into some of these in a little more detail. I already talked about AI applications in mitigation and adaptation. So first, maybe diving into AI applications that increase emissions. So AI has been used for years in service of emissions of intensive industries such as oil and gas and mining. In general, the use of AI is to make these certain operations within these industries, cheaper or more efficient, and potentially or often in a way that can then impede the transition to cleaner or more climate-friendly alternatives. So, for example, in a 2020 report, Greenpeace described the ways in which major tech companies such as Microsoft, Amazon, and Google are partnering with oil and gas companies to accelerate applications in that sector, in the oil and gas sector, both through the use of cloud computing technologies and through the use of AI. So focusing in on AI, for example, AI is being used to do advanced subsurface modeling to facilitate oil and gas exploration activities. It's being used to optimize drilling and pipelines to facilitate extraction and transportation. And it can also help with marketing to increase the sale of these technologies. This unfortunately can have and has had large impacts. So in case studies of specific projects, it was found that AI boosted productivity in some oil and gas projects by as much as 5%. And on a macro scale, some estimates predict that AI could generate, $425 billion in value for the oil and gas sector by 2025, potentially impeding the energy transition. So it's really important to think about, again, these kinds of impacts that AI may potentially have on the other side, and to think about, policy and innovation funding strategies that try to, mitigate some of these impacts. Another category of applications is AI applications that, you don't necessarily think of as directly impacting the climate, but that could potentially actually have huge impacts on the climate. So, one of these ways is I talked earlier about, rebound effects. So making something more efficient can potentially increase how much it's used. There's another effect called lock-in. So lock-in effects refer to when, a particular technology enters the market first and significantly, dominates and shapes that market in a way that prevents other alternatives, for example, greener alternatives, from entering the market. So given that AI is often used to increase the efficiency of things or to, give a particular technology a competitive advantage, AI can and often does contribute to both rebound and lock-in effects. So to make this more concrete, let's take the example of autonomous vehicles. On the one hand, autonomous vehicles can help reduce the energy consumed by any particular drive, for instance, by driving cars in more efficient ways. But on the other hand, autonomous vehicles could increase the demand for driving by making it easier to drive. That's the rebound effect. And especially if they're employed in private vehicles, that entrench the role of individualized transport instead of helping a shift to public transport options such as rail. So that's the lock-in side of things. So this could, increase potentially the overall energy consumed. And if that energy is coming from fossil fuel sources, the emissions associated with that. So the impacts here are unclear, but importantly, they're shapeable. We really do have a choice as to whether we develop autonomous vehicles in a way that strengthens public transportation and multimodal transportation, or whether we do it in a way that weakens them. And this is a choice that we can actively make today through, both our business models, through policies, and also through the kinds of algorithms that we develop. Which of these use cases are they actually facilitating? So a different effect, perhaps more directly, is that AI can drive consumption increases across society, for example, through personalized advertising. This can often increase consumption and therefore increase energy use and emissions. So this is, again, something where the use of AI in an application where maybe we don't think of it as climate relevant actually can have potentially large impacts on the climate. In general, AI expertise and the resources to develop and shape AI are also, concentrated among specific companies and actors, and that can, entrench the role of those with power in society. And since I mentioned earlier, climate action will require participation from across society. This can be a systemic effect that, doesn't necessarily directly impact emissions, but can really affect society's ability as a whole to really contribute to climate change mitigation and adaptation strategies. The impacts of these things can be really hard to measure, but they're really important to account for either way. And in particular, again, many of the applications that I've talked about here aren't ones that you might immediately identify as climate relevant, but they indeed potentially have very large impacts for the climate. So, in some sense, if you work on AI and machine learning, for better or worse, your work probably impacts the climate change in some way. Okay. So far I've talked about mostly the applications of AI, and I want to spend a few minutes diving into the energy use of AI itself. So from a macro perspective, while there aren't exact numbers on AI, the International Energy Agency estimates that data centers consume about 1% of global electricity, and that this electricity demand has remained, roughly constant over a number of years because of efficiency improvements in hardware. This effect may or may not persist into the future, but this has sort of been the trend so far. The emissions associated with that energy use then depend on sort of the amount of electricity that's consumed, and also the carbon intensity of that electricity. So for example, are you running on renewable or low carbon energy? In addition to this, there's also what's called the sort of embodied emissions associated with the underlying hardware, which for the data centers are in the order of maybe 1/10 of the emissions coming from electricity use. So the overall emissions from data centers are noticeable, but still fairly small, and AI accounts for some fraction of that. So overall, at least from an emissions point of view, the applications that we use AI and ML for, both positive and negative, are likely to have a larger impact on global emissions than the energy use of the models themselves. That said, we as AI and machine learning researchers, we certainly should be thinking about and addressing the energy use of these models alongside their application level impacts. Data centers, AI and machine learning, like every sector across society, will need to hit net zero. In particular, over the past few years, the largest AI models, specifically those from deep learning, have grown in size and computational requirements, as shown by the graph on the slide, and also, therefore, in their energy and emissions requirements. For instance, Strubel et al. In 2019 showed that training BERT, the large language model, on a GPU had approximately the same emissions impacts as taking a flight across the United States. In addition to energy implications, and maybe what I am the most concerned about, is that this has huge equity implications. It can be really costly from a monetary perspective to pay for the energy required to develop these really large models, which means that many people and communities are fundamentally boxed out from participating in their development and also in the subsequent applications. So this has many different, future research directions and considerations associated with it, including, work to develop energy efficient models, and also viewing energy efficiency as a core consideration alongside accuracy. So we've established that climate change is a really important and cross-cutting societal issue. And we've established that AI affects climate action in many different ways. So in some sense, whether you're working on an explicitly climate relevant application or not, your work probably affects the climate. So how can you address and shape these impacts? So one consideration here is to think about the emissions impacts of your work. As I've mentioned throughout the talk, these impacts can come in various forms through, for example, the immediate impacts of the applications that you're working on, and also through the system level shifts that your work drives, as well as through the energy impacts of maybe the models that you're running themselves. One route here, and of course, a route that I really, really encourage everyone to take, is to work on applications of AI that explicitly attempt to tackle climate change. And I definitely, encourage this route. There's really a lot of very interesting work in this area that's very needed. For example, my work focuses on how do you use AI and machine learning to facilitate the integration of renewable energy into electric power grids through methods for forecasting, optimization, and control. So definitely a pitch for, please, if you're working on AI, definitely consider working on climate relevant applications. But even if you're not doing that, if you're working on AI more generally, it likely makes sense to ask, what are the emissions impacts of my work? And how can I go about shaping or shifting these impacts? So for example, to bring back the autonomous vehicles example, if you're working on autonomous vehicles, can I choose to strengthen public and multimodal transit instead of strengthening private transit? And in general, the goal here should be to be holistic. So for example, building an energy efficient model to do something evil isn't necessarily good for the world, even if that, again, model is energy efficient. And in fact, saying that you'll make your models more energy efficient while not considering what you're actually using them for is a common form of greenwashing. So really the goal is to be, again, holistic in thinking about these effects more broadly. Another consideration is to apply a climate justice lens. So climate justice is a framework that acknowledges that climate change disproportionately affects marginalized communities, even though they largely did not contribute to the current state of the climate crisis that we're in. And so climate justice takes an equity-centered lens to tackling climate change, both by ensuring that we are, strengthening marginalized communities in the way that we actually work to reduce emissions or build resilience, and also making sure that those communities really do have a spot in really owning a lot of these solutions as well. So given that, AI and machine learning are fundamentally accelerators of the systems in which they're employed, I think Timnit Gebru and others have said this, right? AI and machine learning accelerate the systems that they're in. It's really important that we think deeply about whose systems we're accelerating and how that interplays with, power shifts and shifts in capital across society. So unfortunately today, I think, as I've said a few times, AI and expertise and computational resources are often held among specific companies and universities. They're often concentrated within a select number of countries. And if we're not intentional about it, this can lead to somewhat of a rich get richer phenomenon where, those who do have the relevant knowledge and capital and data to use AI benefit from it exclusively. And that can widen the gap between the haves and the have-nots. On the other hand, though, right, there's something we can do about this. So to address this, this means thinking intentionally about, who you're working with and who are you centering in your work, and whose problems you're solving. So from a methods perspective, for example, are you always developing methods that assume you have, ubiquitous and relatively clean data that, for example, you often see in social media companies? Are you developing methods that work with, less data or more difficult data environments like those often faced by, for example, grassroots organizations? From an applications perspective, are you solving exclusively the problems faced by, for example, large industrial agriculture companies that have access to huge amounts of automation and machinery? Are you also thinking about ways to, for example, increase the participation and effectiveness of smallholder farmers by empowering them through, AI insights and analytics? This also means thinking intentionally about who owns the data or solutions that you use or generate. So for example, there's a growing trend where tech companies provide data and analytics to city governments on various issues, so including climate relevant issues. And this often happens in ways where the tech companies, hold power over the data and analytics rather than the government or the public truly owning them. So what does that mean in terms of who has power in society, and what are ways to potentially shift or diversify this paradigm? I think this is something to think about in these collaborations with, players from across society, again, to think about what are the actual structures behind who owns and benefits from these. And in general, I think it's asking, how to make sure to center or empower marginalized communities in one's work. So who's at the table during scoping, development, and deployment, and whose expertise, both academic expertise and lived experience, are you taking into account? A final consideration I'll pose for researchers is to be responsible about the way that you communicate about AI and machine learning, be it through your papers, grants, blog posts, or other public communications. So increasingly in many societal domains, the people who read about our work are not just people in the AI and machine learning community. They're researchers in other areas, but also, policymakers, funders, and so forth. And in particular, machine learning is a hot area, and we get a disproportionate amount of funding and attention compared to people in other fields and communities. But importantly, in climate change and many other areas, machine learning is not a silver bullet. It's not applicable everywhere. And in those cases where it is applicable, it's only one piece of the puzzle. So I already talked about this example of where, installing smart thermostats in buildings can be really useful, but it only makes sense if you take the less flashy action first of maybe insulating your building. So as a result, when communicating about your work, it's extremely important to be clear about the broader context of your work, where it applies, and also where it's limited. Not doing this can lead to misunderstandings about your work and what it can actually do. It can lead to misunderstandings about machine learning as a whole, which in turn may lead to maybe ML to be applied in, irresponsible or ill-suited ways. And the sum total of this can sometimes mean that our work in AI and machine learning can sometimes incorrectly drown out other important and impactful, but potentially less flashy work across society by diverting attention and funding from that other work. So some considerations here include, making it clear in papers and public communications what AI and machine learning can and can't do. So really being honest about the capabilities and limitations of your work. And also being sure to talk about what alternative methods or perspectives may make more sense in certain contexts, really, again, contextualizing your work and really making the trade-offs of that work very, very clear. So in addition to, academics, I think there's also a lot that policymakers can do here, both to support the responsible development and deployment of work that uses AI to address climate change, and also more broadly to align the use of AI overall with climate goals. So just a few weeks ago, for example, my organization, Climate Change AI, in partnership with the Center for AI and Climate, wrote a report for the Global Partnership on AI, which is a sort of multi-stakeholder initiative drawing participation from 18 national governments and the EU. To basically try to provide recommendations for government action at the intersection of climate change and AI. And actually, one of the other keynote speakers later this week, Nico Miale, was also one of the co-authors on this report. So I definitely encourage you to check out his talk as well. This report is available online at the URL on this screen. And I definitely, again, encourage you to check it out, either if you are somebody who's working in government or you're somebody who, is interested in thinking through and advising governments on what exactly they can do in this area. And so in the report, we dive into a couple of different ways that AI can be used. So first is to support AI applications in climate change mitigation and adaptation. This involves, ways to foster the responsible development of and access to data and digital infrastructure. So this is, data, simulation environments, test beds, model libraries, computational hardware, all of that good stuff that can really support the development and adoption of AI for climate applications. It also talks about, ways in which governments can help target research and innovation funding to develop interdisciplinary and cross-sectoral work at this intersection of AI and climate change that is really guided by climate impact. As I've sort of mentioned in various points throughout the talk, doing impactful work in this area will really require bringing together stakeholders from many different perspectives and communities. So research and innovation funding can play a role in making that actually happen in an impactful way. And governments can also, support the deployment and systems integration of AI for climate applications through, policy design, market design, business models, and in particular in highly regulated sectors like energy, transportation, agriculture, heavy industry, where it can be difficult to deploy innovations. Governments can also play a pretty big role in reducing AI's negative impacts on the climate or shaping AI's impacts on the climate as a whole. And the biggest thing here is, making climate change a central consideration when fostering the development of AI-enabled technologies in general, considering both the applications they're used for and the direct emissions. And I sort of talked more in depth earlier, of course, about the different ways in which that relationship between AI and climate change can play out. And of course, there's a big role for governments and there's a big need to sort of build cross-cutting capabilities across society. So across governments, both national and local and international, national, local, also civil society, also academia, smaller players, et cetera, just building capabilities across a wide range of stakeholders by, embedding responsible AI principles into the design of various kinds of initiatives and governance structures. And that includes fostering the inclusion of participants from across, civil society, governments, the global South, et cetera. It also means, providing mechanism to collect various kinds of data on the impacts of AI that can help, establish measurement standards and reporting frameworks. It also means, building capacity for implementation, evaluation, and governments, in the form of, educational programs, providing skills and talent, building tools and best practices. And it also means international collaboration to make sure that different entities are really pooling resources and coming together to not duplicate efforts, and in fact, to overall strengthen the efforts that can be pursued in this area. So with that, I want to thank you so much for listening, and I welcome any questions. And on the slide, there are sort of some additional resources, both this paper on tackling climate change with machine learning that details the various ways in which AI machine learning can be used to address climate change, the policy report from the Global Partnership on AI that I just described, and also a preprint on sort of that goes into more depth on the different ways in which AI and climate change interact with each other. So my contact information is on the screen. And again, looking forward to taking your questions now.
Thank you for this amazing presentation. It was very interesting to listen to. You have a lot of information, useful information in your presentation. We already have a question here for you, so I'll read it. So, given that AI systems cannot help but negatively impact the environment to a significant extent, do you think we should use AI as a tool to tackle climate change at all? Namely, do you think there is a threshold where benefits overcome risks, or that we should think out of AI to tackle climate change?
Yeah, so there's a lot to unpack in that question. So it's a really great question. So the first part, given that AI systems can't, help but negatively impact the environment to a significant extent. So I think there's something to unpack in there, which is that there's a big diversity in the, kinds of AI and machine learning models that are available. For example, a linear regression model that runs in a few seconds on your computer has a negligible emissions impact, but depending on what it's used for, can have a really, beneficial impact. Whereas, of course, when you start to get to these larger and larger models, that trade-off becomes more salient. Is the application or the emissions of the model more salient here? So I think thinking through, okay, like at any situation, evaluating holistically those impacts, what are the application level impacts? What are the impacts of a model? Where do I have levers to shift those two things? For example, do I need to use a very large emissions intensive model, or can I use a small one that would tip the balance even further in favor of the application? I think that sort of, that analysis is really important to do. That said, I think that in a lot of cases, for example, AI and machine learning applications in the electric power sector, in buildings optimization, there are actually a lot of applications where when you do that analysis, that the sort of, impacts of the applications do, really win out here. But this also can go the other way, right? Again, if you develop an energy efficient AI and machine learning algorithm for surveillance, right, the impacts of the applications win out again, but maybe not in the way that you want. So I would say that there is, for any individual application, you should be doing that analysis. I think it's really hard to say, like, we should just set a societal threshold. And then also, I think the other part of the question is, should we think out of AI to tackle climate change? I mean, yes, but I don't think that's mutually exclusive, right? As I mentioned, there are lots of climate strategies that don't need AI and machine learning at all. We definitely should be doing all of those, but I think we also should be thinking through, are there specific places that AI and machine learning can really help accelerate action there? And if that's the case, we should make sure that's part of our toolkit. So it's not about sort of centering AI and machine learning. It is really about centering the climate impact and doing all of our thinking and analysis around this really very holistically.
Thank you for the answer. We have another question here, which is the Climate Change Conference, so COP'26, just ended. Any mention on AI topic?
Yeah, it's a great question. So for those who don't know the structure of COP'26 or the UN Climate Change Conference, there's sort of two main components to it. So one is the sort of climate negotiation. So, different countries trying to figure out, what are the targets that we'll each have? How are we going to deal with things like emissions trading or loss and damage or reparations to the global south? So that's sort of one aspect. And then the second aspect is there are a lot of, there's basically like a conference in the same way you might think of an academic or industry conference going on the side, where there are different, presentations that are attended by, people across different sectors and stuff like that. So in that sort of second part, in the conference part, there was definitely discussion of AI and machine learning. So, my organization, Climate Change AI, held some events, for example. Other organizations also held some events. And there was definitely a lot of discussion as to, where can AI and machine learning be supportive in climate action. As far as I know, AI and machine learning did not come up in the negotiations itself. And I actually think that's a very good thing, right? Again, as I mentioned earlier, really, there are many aspects of this that should be focused on the end goal, which is climate. So it's not sort of, in my opinion, the role of the climate negotiations to say, okay, we're going to get to these emissions, we're going to take these concrete strategies. So the negotiation should be doing that, right? We need to decarbonize our power sector. We need to, hit these targets in the power sector over time. But it's not the role of the negotiations to say, okay, and AI and machine learning should be used in this area. I think it's really, I'm the sort of negotiations in that aspect really focus on what are the goals, right? And like, what are the concrete macro steps that we need to do to take that? And I think sort of outside of that, the conference, civil society portion, et cetera, was then focusing on how do you actually do that concretely? And that's where the AI machine learning discussion came in.
We have another question here. So as an AI researcher, what do you think is a good way to gain the necessary knowledge to make sure your work is not having a negative impact once your work is part of a bigger chain of progression towards a final output you might not have control on? If you have any suggestions or thoughts for other researchers on this topic.
Yeah, that's a really great question. And it's really tough, right? In situations where maybe sometimes you feel like one cog in a larger machine and you don't sort of have control over the machine. But the ways I can think of to do this, speaking at a high level, are one, I mean, in some sense, gaining as much, talking to as many people with different perspectives who have the ability to have some impression of maybe what happens down the line. So if you're at a company, maybe, you know, talking to relevant people who sort of are doing the downstream deployment, also bringing in external people who, for example, if you're developing something, you know, at a machine learning consultancy for the energy sector, making sure you sort of have energy experts and climate impact assessment experts and people sort of in the room. In a way, no individual is ever going to have all of the knowledge needed to do this assessment. So I think there is some benefit in sort of making sure that you sort of are building a good network of people around you who really do have those different sets of expertise, so you can sort of talk about those things together. The other thing you can do is get involved in policy. And I actually, when I say policy is sort of the procedure through which an organization makes a decision or takes an action. So we often think of policy as public policy that is set by governments, but different organizations also have policies, right? Universities have policies around how research is developed and deployed. Companies have policies around this. So to the extent to which it's possible to also shape some of the broader discussions in your entity around some of these macro questions, right? How do we evaluate whether research is impactful and responsible, et cetera? And how does that affect the way in which we do research? Getting involved in those policy decisions at various levels can be a way to sort of, even if you're not sure what your specific research is going to do down the line, to sort of shape the decisions of that entity as a whole in a way that helps both hopefully your project and projects more broadly.
Right. And we have another question. What do you think is the relationship between activism and research? I remember there was an article on the Guardian wondering whether journalists should aim to be neutral and objective in reporting climate change, or whether being neutral in this case required being an activist on this topic. Do you think this works similarly for researchers working in the sphere of AI and climate change?
Yeah, this is a really good question, sort of the relationship between activism and research. And being frank, it's one that I've struggled with in my own work, both in terms of, you know, activism related to both specifically the topic I work on in my research, AI and climate change, but also even to other things that, you know, are not necessarily directly what I'm working on in research. I think the answer to that is it depends and is tricky. I think that neutrality can often be an argument for inertia and for locking in some of the very systems that have, for example, caused climate change and the various inequities that we have in society today. And I think it is well backed by scholarship that we need to shift those systems. At the same time, there are people who will view any argument for, you know, for example, transformational justice as being activist as opposed to being backed by scholarship. So I think that is something that is difficult to navigate, but I as an individual, but I think activism and research are, you know, they should not necessarily be kept separate. They are highly related. I think, for example, activism in climate justice has caused the research community to shift in the last few years how it thinks about climate justice, and that would not have happened without activism. So like, I think it's really important to, I think there is a strong relationship here. I don't necessarily have a concrete answer to, for example, this question of how any individual should balance activism and research as they go forth. I think that's a really tricky question, but I think activism has a really strong role in pushing researchers to think about issues that maybe are outside the sort of predominant paradigm at a given time, and that research has a role in sort of providing, you know, various kinds of data, scholarship, et cetera, to support activism as well.
All right, I'm not sure if we have any more questions here. If not, I would like to go back to one thing that you mentioned regarding the AI applications, meaning that sometimes it happens that a specific application goes and locks the market, right, in a way that it blocks other better applications from entering. My question is, do you think that this happens much? So this situation in which one application is locking the market and possibly other applications are being produced, for example, in research, but cannot make this jump through this gap between what's research and what's being actually deployed into the field and being used in this case for AI climate change?
Yeah. So I think it happens in many like very conspicuous examples. So for example, I mean, like the fact that we have roads that, you know, are often centered towards cars, and then we build more roads that further like entrench the role of cars, and we just have trouble sort of shifting over to other modes here. I think it's a very prominent example, and I think these sort of lock-in effects appear everywhere. I am not going to go into an opinionated rant about, for example, I mean, there's of course a lot of discussion around, you know, tech companies and whether the social media platforms or web platforms, et cetera, that they host, you know, are these monopolies? Do these lock out other things in practice, et cetera? I think there's a lot of discussion around that. But so I guess suffice it to say that I think in the context of climate and in broader context, I think there is often this question of, you know, is the solution that a particular provider is putting out there blocking out other solutions from entering? And I think this is, you know, something that we do actually see play out quite a lot.
And we got a final question, probably, which is what would be the team you'd gather to get involved in policy by different organizations?
Could you say that question again?
So what would be the team you would gather to get involved in policy by different organizations? So probably can see the question in the chat. I'm not sure if you can open it.
I see it. Okay, cool. Yeah, so I think it depends. So if it's an academic organization, imagine it's like your university. I think there it's important to consider, depending on what the issue that you're pushing for, right? Do various power structures and hierarchies within the university matter? So for example, if you're a student, in this case, does it also make sense to make sure that there are professors on board or administrators on board? If you're also thinking about, for example, what is the effect of the research in a university on the broader community, then of course you want broader community organizations to be involved in that, right, and shaping that. Similarly, for a company, I think it's worth thinking about sort of what are the internal power structures within the organization and sort of whose buy-in do you need to actually make change within that organization? And then given the type of change that you're trying to make, who is affected by that particular kind of change and what external perspectives do you need? Within public policy, of course, sometimes the issues that are addressed are much broader. So I guess I would say it's important to make sure that there's representation across different sectors. So academia, industry, both large and small, civil society, again, both large and small entities, and also that there's, you know, a sufficient amount of, you know, diversity along, you know, various axes in terms of, you know, age, race, gender, class, country of origin, like various things like this, just making sure that sort of different perspectives come into play. In various kinds of expertise as well. So this depends on, for example, if I'm doing work on AI in the electric power sector, it's also important to make sure, for example, power sector experts are there. So I think it depends, but I guess, the generalizing factor there is think about sort of who needs to be on board in order to adopt that. And so what kinds of people need to be in the room to make sure that sort of the people who would actually have the power to do something about it are there and are able to be on board. And then what is the sphere of influence of that particular change? Who does it affect? And as a result, like those folks who would be affected should also be part of that team.
Right. Thank you. And maybe we close this session. I just want to thank you for your amazing presentation and also for this discussion and wonderful way that you answered all these questions. I hope that you will have the opportunity to join another session or two of our conference. And for those watching the conference, we will start a new session in 5 minutes. So the next session will be a roundtable on AI and the environment, and it will be shared by Marta. So stay tuned, and we will